Okay, we're back with the law of sines and the side-side angle. We just saw that letting angle A be 65 degrees and side A being 6 and B being 7, there is no angle B that will fit this. This triangle doesn't work, so we will use the t-shirt of disgust, and we'll get rid of this one. Let's do another one though. So side-side angle, basically we're given two sides and an angle. And what color? How about some blue, I guess. So we're given that B is 50 degrees in this one. What else are we given? Little b is 12. And little c is 11. Let me make sure this is right. Okay, so now I'm going to try and draw a semi-reasonable representation. B is 50 degrees. B is going to be in this corner. Oops. Yeah, that's a little fat. You do get a little better at this after trying for a while, but okay, so maybe that's 50 degrees. B, okay, so little side B is over here, so this is angle B. And this is supposed to be 12, and C is supposed to be 11. So, okay, maybe this. Okay, so here is C. This is little c. This is supposed to be 11. Little b is supposed to be 12. Here is A, and here is little a. And let's put our stuff in here. So this is 50 degrees. Oops, and this is 11, not 1. Okay, so what do we have, and what's this SSA? This is side, side, and an angle. Basically, we got a couple sides and an angle. That's what they've given us here. Well, we know then by the law of sines that the sine of B, which is 50 degrees, divided by 12 must equal, what should I do? I guess I have this, so I'll use this angle C. The sine of angle C divided by 11. Multiply both sides by 11, and I have 11 times sine of 50 degrees over 12 is equal to sine of C, whatever angle C is. Let's figure out what that is. So this is 11 times 50 degrees sine divided by 12. Okay, so this says sine C is equal to 0.7022 and some change. That means that the arc sine of 0.7022 and some change is, and I don't know yet, I'll find out in a second, arc sine says 44.60 degrees. So this is supposed to be 44.60 degrees. And so far, this seems reasonable. If that is 44.60 degrees and this is 50, this plus 50, and now, so these two are 94.6 degrees and change. So this right here is 180 minus this. 80. This is 85.4 degrees, basically 40 degrees. Okay. So now what is sine A equal? Well, there's a couple things that we can do here. Let me actually see what we were supposed to do for this. Draw a picture. Oh yeah, we must find the angles AC and side A. Okay, so now remember, so this is what we said. This is, the arc sine of this was approximately 44.60 degrees. What if this was the case? Remember when we had one that looked possibly like this or this? We didn't know which one of these it was going to be. Well, so here is, this could be A and this could be A. We have this swing out. Basically, it's going to be this one, or it's going to be 180 degrees minus this one, right? 4.60. And the reason why that is because of, remember on the unit circle when we're looking at sine, the sine from anywhere from here to here, the sine of this, what is this? Here's some angle alpha, right? The sine is going to be, here's r, here's y. The sine of alpha is y divided by r, back from a billion years ago, right? What is it also? Well, what about this right here, this picture right here in the second quadrant? This is pi minus alpha going this way, right? Because here's pi, we went this way, it's subtracting alpha. We know that this is the angle that it actually represents, and this is the picture. You'll notice that, well, I'll just do this, what the heck? Oh, well, I'll leave this here. It is the case that the sine of pi minus alpha is equal to the sine of alpha if alpha is between 0 and 90 degrees. Basically, if alpha is in the first quadrant from this picture. How can you prove that? You should remember this formula. Sine of sine of x minus y, in this case it's pi minus alpha. This is going to be sine pi cosine alpha minus sine alpha cosine pi. Sine of pi is 0, minus sine alpha cosine pi is -1. This is -1. This is sine of alpha. Hopefully that rings some bells. So here's what you need to do. We figured out that the arc sine of the first thing we got was 44.60 degrees. It could also be this, which is, let's see, 180 minus 44.6 is 135.4 degrees. Does this work? And what do I mean by does this work? Well, if this angle is actually 135.4, then 135.4 plus 50 is 100, so this plus 50 is 185.4. No, we can't do that. This angle is too large. If it was 135.4, our triangle would have more than 180 degrees. And the saddest thing is in this course we're not doing any spherical trigonometry. In spherical trigonometry, you can have triangles that actually have more than 180 degrees, but you'll have to pick that up some more later. So basically what we've done is we've figured out that this is in fact the angle that we need, and that this is the other angle. Let me clear some of this junk up here. Okay, I'll get rid of this, and this. So there's one last thing that we need to do, and that's figure out what A is. And A is a piece of cake because we have this, so we know that the sine of 85.4 degrees divided by little a is equal to, I can pick either one of these. Good question here. Which one should I pick? Should I say is equal to the sine of 40 degrees over 12, 50 degrees over 12, because that's B, right? Or should I say it's equal to the sine of 44.6 degrees over C, which is 11? Here's the deal. This was given to us. We're not approximating. This was approximated. If you use an approximation in an approximation, it'll get a little farther off. So I'm going to use this, the given information, to derive this. And my producer says we is running out of time. Basically, this means that A is equal to 12 sine of 85.4 degrees divided by the sine of 50 degrees. I did the computation real quick so we didn't run out of time. This is, little sine A is 15.614 and change. We'll just call this 15.61. See you in a minute.